Everyone, welcome to your physics class of class 8th. I hope you all will be fine. Students, in our previous video we were doing lesson number 5. So today in this video we will continue doing that lesson, and also we will complete the question answers of that same lesson. Okay, so let's begin our today's class. Focus and focal length. So as you can see here in this diagram number, figure number 5.20a, in case of a concave mirror, the reflected rays after reflection meet at a point F, this point on the principal axis, and this point is called the focus of the concave mirror. And in case of a concave mirror, the reflected rays do not meet at any point. As you can see here, these rays do not meet at any point, but they appears to come from a point that is F on the principal axis behind the mirror. You can see here, this is a point F from where they appear to come from, and this is called the focus of the convex mirror. Okay, therefore we can say that the focus of a concave mirror is a point on the principal axis at which the light rays incident parallel to the principal axis meet after reflection from the mirror, and the focus of a concave mirror is a point on the principal axis at which the light rays incident parallel to the principal axis appear to meet after reflection from the mirror, and it is represented by the letter F. Now, what is focal length? The distance of the focus from the pole of the mirror is called the focal length of the mirror. Okay. Now, rules for making ray diagram in a spherical mirror. First is, the object is kept in front of the reflecting surface on its left side. Rule number 2, the object is always kept on the principal axis such that it is perpendicular to the principal axis and its foot touches the principal axis. And the third one is, for constructing a ray diagram, take at least 2 rays of convenience whose paths can be traced after reflection. So these are the rules for making the diagram in a spherical mirror. Now, convenient rays means which rays we can take for our convenience, to our convenience. So first one is, a ray that is passing through the center of curvature is reflected along its own path. Means a ray of light which passes through the center of curvature reflect along its own path. Second, here you can see in this diagram, the ray which passes through the center of curvature reflect back to its own path. This is a reflected ray, and incident ray, and this is a reflected ray. Reflected ray passes along its own path, reflected along its own path. Second is a ray parallel to the principal axis. A ray parallel to the principal axis, a ray that incident parallel to the principal axis after reflection passes through the focus. In case of a concave mirror and in case of a convex mirror, it appears to come from focus. Okay, as you can see here, this is a case of convex mirror and this is concave mirror. Now the third is a ray passing through the focus. A ray passing through the focus in case of a concave mirror or appearing to pass through the focus in case of a convex mirror is reflected parallel to the principal axis. Means a ray of light which passes through the focus reflect back parallel to the principal axis. Okay, in case of concave mirror and in case of convex mirror both. Now, real image and virtual image. Real image is formed when reflected rays actually meet at a point, and virtual image is formed when the reflected rays meet on producing them backward. It is inverted and it is erect and upright, and it can be obtained on the screen, and virtual image cannot be obtained on a screen. Now, images formed by a concave mirror. When an object is at infinity, the image formed at the focus, image is formed at the focus when the object is at infinity. As you can see here in this diagram, the rays here are coming from infinity. These are the incident ray, and after reflection, they meet at focus. So the image is formed at the focus, and it is real, inverted, and highly diminished. Means the size of the image is diminished, and its nature is that it is real and inverted. Okay, as you can see here in this diagram. Now next is, when an object is beyond the center of curvature. When the object is beyond the center of curvature, you can see here This is the object AB. It is beyond center of curvature. We have taken two rays, one parallel to the principal axis and other that passes through the center of curvature. The ray that is parallel to the principal axis passes through the focus, and the ray that passes through the center of curvature reflect back through the center of curvature, and they both appear and they both meet at this point somewhere between the focus and the center of curvature. So this is the point where they meet. So this is the image of the object AB, and you can see from the diagram that the image formed is real as it is obtained on the screen, and it can be obtained on the screen inverted. You can see here B dash A, because this is the point A dash, and this and is smaller in size than the object AB. Okay, now the third case is when the object is at the center of curvature. You can see here in this diagram, when the object is at center of curvature, two rays we have taken here, again one parallel to the principal axis and second one which passes through the focus. So with the ray which is incident parallel to the principal axis, which is parallel to the principal axis and incident on the plane mirror, passes through the through focus, and the second ray which passes through the focus reflect back to the parallel to the principal axis, and they both meet at this point, that is at the center of curvature, but in the image formed is inverted. Okay, so the ray which when the object is at center of curvature, the image is formed at the center of curvature C. The image formed is real, inverted, and of the same size as that of the object. Now the fourth case is when when an object is between center of curvature and focus. So when this when the object is somewhere between the focus and the center of curvature, you can see here AB is in between focus and center of curvature. Again, we have taken two rays, one parallel to the principal axis and this other is which passes through the focus. So they both meet at the point somewhere beyond this center of curvature. So this is the image of the object A B. Okay, so this A dash B dash is the image of this object A B, which is formed beyond the center of curvature, and the image thus formed is real, inverted, and bigger in size than the object. Okay, now fifth is when the object is at the focus. So when the object is at the focus, here you can see when the object is at focus, the image is formed at infinity. As you can see here, they do not meet anywhere here, so the object is formed at infinity and it is real, inverted, and highly magnified image is formed. Now sixth is when an object is between the focus and pole. So when the object is between the focus and the pole, okay, so image these reflected rays appear to come from this point A dash B dash, means they meet at this point here behind the mirror A dash B dash. Okay, so in this case the image formed is behind the mirror, and the image is virtual, erect, and the size of is bigger than the object. Okay, so these are the images that is formed by the concave mirror. Now you can see here images formed by a concave mirror for different position of the object. So we have discussed here six positions. So all the six positions, the position of the image and the object and the nature of the image, you can see, you can read from here also. Okay, this that we have discussed here in the diagram, you can briefly read it from here also. You have to read this table. Okay, now uses of a concave mirror. It is used as a shaving mirror, as a reflector, as a doctor's head mirror to converge solar radiations in a solar cooker, and also in floodlights as a reflector. Okay, now uses of a convex mirror. It is used as a rear view mirror, as a reflector in street lamps, and as a vigilance or anti-theft mirror. Okay, now by this the explanation part of our lesson number 5 is over. Now we will do the question answers. Okay, question number 1 is state the speed of light in air, water, and glass. So these are the speed of light in air, water, and glass. You can write your answer from here. Either you can take the screenshot or you can pause the video and you can complete your work in your notebook. Question number 2. How does the speed of light determine the optical density of a medium? If the speed of light in a medium is less than the speed of light in air, this means that the medium is denser than air. And if the speed of light is more in the medium than the speed of light in air, this means the medium is less denser than air. Okay, now question number third. Which is optically denser, water or air? Give reason. Water is optically denser as the speed of light is less in water. So this is the speed of light in water and this is the speed of light in air. Question number 4. Out of air and glass, which is optically rarer? Give reason. Air is rarer. Speed of light in air is more than the speed of light in glass. So these are the speed of light in air and glass respectively. Question number 5. What do you understand by diffraction of light? The change in the direction of path of light when it passes from one transparent medium to another is called refraction of light. Question number 6. Describe an experiment to show that a light ray bends when it passes from one transparent medium into another transparent medium. So experiment is given here. You can see here and you have to draw this diagram also. Okay, so you can take the screenshot and then you can complete this answer in your notebook and you have to draw the diagram also. Question number 7. Draw a ray diagram to show that the depth of a vessel containing water when seen from above appears to be less than its real depth. Okay, you can draw the diagram from here or also you can make the diagram from the book. For question number 7, you can make this diagram that is given in book on page number 83, figure number 5.6. Okay, you can draw this diagram for question number 7. Question number 8, define the following terms: incident ray, refracted ray, angle of incidence and angle of reflection. So you can write the answer from page number 82. Here are the answers. Incident ray, the definition of incident ray is given here. The ray of light falling on a surface separating two media is called the incident ray. Refracted ray, the ray of light traveling in other medium is changed in the change direction is called the refracted ray. Angle of incidence is the angle between the incident ray and the normal is called the angle of incidence, and the angle between the refracted ray and the normal is called the angle of refraction. Okay, this is answer number 8. Question number 9. A ray of light falls normally on a glass slab. What is the angle of incidence? So when a ray of light falls on a glass slab normally, the angle between the normal and the incident ray is 0. Therefore, the angle of incidence is 0. Okay, you can make this diagram also. Question number 10. A ray of light travels from rarer medium to a denser medium. How will it bend? So when a ray of light travels from a rarer medium to a denser medium, it bends towards the normal. So this is a diagram for this answer or this question. Question number 11. A ray of light travels from a denser medium to a rarer medium. How will it bend? So when a ray of light travels from denser medium to a rarer medium, it bends away from the normal. Okay, so you have to draw this diagram. Question number 12. The diagram given below in figure shows a ray of light AO falling on a surface separating two media. Draw the refracted ray in each case. Means from air to water and from water to air. Okay. And also from air to water when the ray of light incident normally. So these are the diagrams you can complete from here. Okay, this is for A. This is A part, this is B part, and this is your answer for C part. Okay. Now question number 13. Draw a right ray diagram showing the reflection of light ray from water to glass. Label it on it the incident ray, the angle of incidence and the angle of refraction. So you can draw the diagram from here. Okay, this is the incident ray. Okay, angle of incidence and angle of refraction. This is incident ray. Now question number 14. Draw the diagram in figure shows a ray of light AO falling on a rectangular glass slab PQRS. Complete the diagram till the ray of light emerges out of the slab. Label on the diagram the incident ray, the refracted ray and the emergent ray. So this is your diagram for this question. Okay, you have to complete this in your notebook. Question number 15. Explain the following. A coin placed at the bottom of the vessel appears to be raised when water is poured in the vessel. So the answer is the coin at at A appears to be at B, that is, the depth the coin observed is less than the actual depth A at A. The ray of light is starting from A, that is denser medium, bends away from the normal due to refraction of light. The coins appears at B at a lower depth. Hence, in the same way, the depth of water to appears to be less deep. Okay, now B is, you can draw the diagram also. Either you can draw it from the book or you can draw from here also. Now B is, question number B is, a straight stick partially dipped in water obliquely appears to be bent at the surface of water. The phenomena is due to the refraction of light. When light passing from denser medium to rarer medium appears to come from Q dash, virtual image in spite of Q. Same is true for any other point of stick inside water. Stick appears to be raised or bent. Now next is question number C. Question number C is, the sun is seen before the sunrise and after sunset. This is also due to the refraction of light. When the sun is just below the horizon, the light from the sun suffers refraction from rarer to denser medium and bends towards the normal at each refraction, and due to continuous bending of light rays, the sun can be seen even when its actual position is just below the horizon, and as a result the sun is seen in advance 2 minutes before it rises above the horizon in the morning. Similarly, in the evening the sun is seen delayed by 2 minutes longer above the horizon after the sun set. Question number 16, what is mirage? Give a reason for its formation. So answer is, hot sand is a rarer medium, and mirage, when it is very hot, an inverted image of tree is seen, which is illusion of eye of water under the tree, and this is called a mirage. Okay, and the reason for its formation is sand becomes very hot during hot noon. The layers of air in contact become rarer, while upper layers of air are still at comparatively low temperature and are denser medium. When the light ray of light from denser to rarer medium are bent away from the normal, when refracted from denser to rarer medium, bends towards the normal, and a tree appears inverted. Okay, this I have already explained you in the lesson while I was explaining you the lesson, so you can write in your own words also. Question number 7, what is a prism? Draw a ray diagram to show the reflection of light through a light ray through a prism. Refraction. So answer is, a prism is a transparent refracting medium bounded by two plane surfaces inclined at some angle. Refracting edge and base are shown in this figure. You have to draw the diagram of this prism. Okay. Now question number 18, what do you mean by the term dispersion? The splitting off or breaking up of white light into its constituent colors as it passes through a refracting medium such as a prism is known as dispersion. You have to draw this diagram also. Question number 19, a ray of light falls on a prism. Draw a ray diagram to show the prism disperses the white light. Okay, again you have to draw this diagram. Question number 20, in figure AO is a ray of light falling on the prism PQR. Complete the diagram till the light emerges out from the prism and falls on the screen. Okay, so you have to draw this diagram. Now question number 21, what do you understand by the term spectrum? Name the various colors present in the spectrum. So spectrum is a band of colors obtained on the screen when white light passes through a prism and splits into its constituent colors. The colors of the spectrum are violet, indigo, blue, green, yellow, orange, red, and the order of the spectrum is Vibgyor. Question number 22. When you are given a disk divided into 7 sectors with colors violet, indigo, blue, green, yellow, orange, and red in them. What would be its color when it is rotated rapidly? So this is known as Newton's color disk, and it is a circular disk taken by Newton to demonstrate the recombination of 7 colors produce white light. A circular cardboard Disk, when divided into 7 sectors and they are painted with 7 colors of Vibgyor, the disk, when rotated at a high speed, appears white. Question number 23. State two laws of refraction of light. Okay, so the incident ray, the reflected ray, and the normal lie in the same plane, and the angle of incidence is equals to the angle of reflection. Question number 24. What is a spherical mirror? A mirror which is made from a part of a hollow sphere is called a spherical mirror. Question number 25. State two kinds of spherical mirror and distinguish them with the aid of proper diagram. So the two kinds of spherical mirrors are concave mirror and convex mirror. And here are the diagram of concave mirror and convex mirror. Silver surface is away from the center of curvature and the focal length is negative in case of a concave mirror, and in case of a convex mirror, silver surface is towards the center of curvature and the focal length is positive. That is, the reflecting surface is away from the center of curvature. Okay, so this is your diagram. You have to draw this diagram also of both concave mirror and convex mirror. You can also draw from the book. Question number 26. Explain the following terms: pole, center of curvature, radius of curvature, principal axis, and show them on separate diagram for each of the concave and the convex mirror. So this is the diagram for pole, both in case of concave and convex mirror. Pole is the geometric center of the spherical mirror. Okay, and this is a pole in both this. You can draw the diagram from the book. Center of curvature is the center of the hollow sphere of which the mirror forms a part. Okay, and it is represented by letter C. Okay, this is for concave mirror and this is convex mirror and this is center of curvature. Radius of curvature is the radius of the hollow sphere of which mirror is a part. Okay, and it is represented by R. Principal axis, it is a straight line joining the pole of the mirror to its center of curvature and extended further. This is principal axis. So students, this is all for today. You have to complete this work in your notebook till 26 question answer, till question 26, and also you have to learn these answers, and after completing your work in your notebook in a neat and clean handwriting, and further question answers I will give you in the next video. Okay, thank you.